Welcome to CS 1401 Video Lecture 1.1, which is Why Computer Science. So, computer science is all across and through our world, our everyday world. It affects our lives in multiple ways, and it's easy to think of these. For instance, just the internet and the World Wide Web through which you're viewing these videos, through your cell phone, which is basically a small computer which is hooked up to a wireless computer network. Your car probably has a lot of computing in it, from maybe you've got traction control, and you probably have computers that control your fuel and so forth. Um, Cars are part of what is becoming the Internet of Things. After all, a lot of cars, through things like OnStar, are already connected to the Internet in some way, and houses through thermostats and security systems, appliances, basically computing as represented by connected things is really inserting itself, becoming part of an important part of our everyday lives. Computing is also a part of government, both in good senses and bad senses. It's clearly part of science and engineering. In fact, it's hard for me to think of a field in science or engineering today which doesn't pretty much highly rely on computing for a lot of its work. Health sciences, medicine, nursing, and so forth, heavily computerized, both in terms of the research that people do, but also in terms of the treatment that people receive. If you go to a hospital room and you see your friend or relative in the hospital bed, they're pretty much hooked up to a bunch of computers. And, of course, entertainment such as video games, television, which comes through computer networks, or a lot of it's computer generated, and movies too, which are now typically projected digitally instead of in an analog way. And most movies have some kind of digital effects in them. So, in many ways, in fact, in ways that it's hard to avoid, computing is part of our lives. And if we want to make a difference in the way that people lead their lives, then computing is the way to go. And in fact, computer science definitionally is doing things with information in ways that are correct, efficient, usable, secure, and economical. That is, we want our systems to be correct in the sense that they do the right thing. We want them to be efficient in the sense that we don't want to wait forever for our results. We want them to be usable so that you and I can pick up an application and use it directly without having to read a 250-page manual or go through a tutorial and so forth. We want them to be secure so that other people can't access our information. And we want them to be economical, both in the sense of being able to afford the applications, but also in the sense of wanting to build systems in an economical way. How can we, an open question is, how do we build especially large computing systems in ways that don't cost too much? Now, all this computing in the world, which we've been talking about, has led to huge demand for people in computing. So, for instance, the Bureau of Labor Statistics has estimated that the demand for software engineers, for instance, is on the rise, with an estimated growth rate of something like 30% between 2010 and 2020. And that's more than double the 14% average growth rate for all occupations. Similarly, in 2009, CNN Money found that systems engineer is the best job in America. Not just the best job in computing, but the best job in America, looking at salary, job flexibility, satisfaction, benefit to society, highest job growth, lowest stress, and greatest job security. In fact, 7 of the top best jobs in America, according to this magazine, were in computing. So, for instance, software developer or computer network security consultant. It's also true that computer science is great preparation for other fields that require logical ways of thinking, logical analysis. That includes the practice of law. Lots of computer science graduates get to go to law school, and law schools really want them. Same thing is true for medicine. I just talked a minute ago or so about how much of health sciences is becoming computerized, and so people who go into medicine with a computer science background have a real advantage. Our students at UTEP also go into careers in intelligence and law enforcement, which are increasingly computer oriented and also have a large element of public service. Just like law and medicine, in computer science you can go on to graduate school and get a master's degree or a doctorate, and in doing so you can become a leader in the field. And in fact, UTEP, of all the universities in the country, we are number one in the terms of Hispanic graduates with a master's or doctorate in engineering and computer science. Well, that's the promised land. How are we going to get there? Well, first, of course, you're going to ace this course. But after this course, you're going to take here at UTEP a course called CS 2401, Elementary Data Structures and Algorithms, and it'll build on what we're learning. In this course, we're going to learn how to program, or at least implement our algorithms in a programming language called Java. And in CS 1401, we'll build on that skills to provide some basic what are called data structures. And in 2301, the course entitled Data Structures, you'll go on to do more advanced work. And 2301, Data Structures, qualifies you to take upper division courses with a whole range of things that are interesting to study. So talk with your advisor about what you want to do in computer science, and understand that the course we're in now lays the first level of foundation that you will build on when you take CS 2401, CS 2302, and your upper division courses. So these courses across your computer science program are going to build a number of skills. These skills include an ability to apply knowledge of computing and mathematics, an ability to analyze a problem and identify and define the computing requirements appropriate to the solution of that problem. So we'll spend a fair amount of time in this course figuring out how to do that. Once we've identified the problem and a solution, then another skill you'll have getting your degree here is an ability to design, implement, and evaluate a computer-based system, process, component, or program to meet requirements. In other words, if there's something we want to do, how do we build a computer system or program that meets those requirements? You'll also learn how to function effectively on teams to accomplish some common goal, and we'll work a little bit on teamwork skills in this class. In this class, we'll also start your study of professional, ethical, legal, security, and social issues and responsibilities. When you graduate, by the time you graduate, you'll have an ability to communicate effectively with a broad range of audiences. And you'll have a broad education necessary to understand the impact of computer science solutions on individuals, on organizations, and on society as a whole. By the time you graduate, you'll recognize the need for and have an ability to engage in continuing professional development. Computer science is not a field that stands still, and if you want to keep up, you've got to keep moving. You'll have an ability to use current techniques, skills, and tools necessary for the computing practice, and you'll have an ability to apply the mathematical foundations you're learning in other classes, algorithmic principles you're going to be learning in this class and in other classes, and computer science theory in the modeling and design of computer-based systems in a way that demonstrates comprehension of the trade-offs involved in design choices. There's probably not one single solution for every problem, and we want you to be able to figure out how to get to the right solution for that particular circumstance or set of conditions. And finally, we'll want you to have an ability to apply design and development principles in the constructions of software systems of varying complexity. In our class, this semester, we're going to be solving problems of pretty limited complexity. We're just starting out after all. And as you mature in the program, you're going to deal with systems of increasing complexity, and you should have techniques for building solutions for problems that are at appropriate levels of complexity. So that's it for this lecture. In the third and final video lecture in this series, our introductory series, we'll talk about how to solve problems abstractly. So I'll see you in a little bit.